Welcome to Math with Mr. P. This is 6th grade math. We are doing chapter 5, lesson 7, graph on the coordinate plane. We kind of touched on this last lesson, so this one will be kind of a review lesson, but we're going to go ahead and talk about how to graph on a coordinate plane. The first things that we need to review are what a coordinate plane looks like. So when it refers to coordinate plane, the term coordinate plane refers to a graph that has an y and x axis. Remember, the y-axis goes up and down while the x-axis goes left and right. These are basically two intersecting number lines. The y-axis number line, the top part are all positive, while the x-axis, the right side, is all positive. On the flip side, y's bottom part is negative, while x's left part is also negative. The middle point in which the x and y axis cross is known as the coordinate 0, 0, also known as the origin. And some people call it the origin point. That is where the lines intersect, and that's actually where you start. Now, you start at the middle, and the first ordered pair tells you to go left or right. The first ordered pair is your x coordinate. Your second ordered pair is your y coordinate. So x will tell you to go left or right. Y will tell you whether to go up or down. You go left if it's negative, right if it's positive, down if it's negative, up if it's positive for y. So, for example, if I were to graph the point 3, negative 5, I would start off at 0, 0 right here, and I would move. Let's go ahead and get rid of that. I would move 3 to the right. So 1, 2, 3. Then I would go down, because it's a negative, 5. 1, 2, 3, 4, 5. My point would be somewhere right here. And this would be 3, negative 5. And then if my point were something like negative 4, negative 2, I'd still start in the middle and go 1, 2, 3, 4 to the left because it is negative. 1, 2, 3, 4, and then down 2 because it is negative. So my point would be somewhere around here, and that would be negative 4, negative 2. The other thing that we need to know are the quadrants. We went over this last lesson, but we're going to go ahead and review here. Remember, the quadrants start, if you're going to number them, always start in the top right corner like you're doing your name. And this will be quadrant number 1, which you'll notice is positive, positive, because you have to go to the right and then up to be in quadrant 1. Then we're going to go counterclockwise. So to the left, we will have quadrant 2. This will be negative, positive, as we must go left first and then up. Continuing on down our path will be quadrant 3, which will be negative, negative, as we go left, then down. And finally, we will have quadrant 4, written as IV in Roman numerals, which will be right and then down, so positive, negative. If you do not have something like this in your notes, it is very important that you do this and study it so you know where the quadrants are, what the corresponding positive negatives are for each quadrant, because this will be questions. These will be questions that are being asked of you on the test. So, back to the book. We have a little map here, and I'm going to go ahead and bust out my textbook because this scan is not 1000% legible. And if you're following along at home, you may want to get your book out so you can see the graph clearly. But we are going to be using this graph to get to certain locations. Maria hid the clues to a scavenger hunt for her hiking club. Use the map to show where she hid the clues. Identify the location of each clue. The first clue is hidden near a tree. So, given that information and looking at the map, our tree is right here at this point. What ordered pair describes this location? So this is the point we're looking at. Remember, we start at the origin, and we're going to move right until we get right underneath the tree, and then up until we get to its point. So according to our textbook, we must go 4 to the right. So our first quadrant, or x coordinate, if it will let me draw, will be positive 4. And then we must go up 2. Since we're going up, it is still positive. So the tree will be located at 4, 2. We went right 4, up 2. Maria hid the next clue at the location reflected across its y-axis. Where is it hidden? Now remember, we learned last lesson when we reflect, we are going to look at x and y, and it tells us it's reflected over its y-axis. So y is going to stay the same. X changes to its opposite. So it'll be located at negative 4, 2. If I go, starting at the origin, negative 4 up to 2, my answer is it's at the library. The next clue is hidden at the library. She walks 3 blocks east and 2 blocks north to place the next clue. Where is it hidden? So I'm going to go ahead and erase what we've worked on so far, because remember, this is something you guys are going to need to know. The north, south, east, and west. You're going to need to know the compass. We live on the west coast. We live on the left part of the United States. So west is to the left, east is to the right. North is up, south is down. So if she walks east 2 blocks, walks 3 blocks east and 2 blocks north to the place the next clue, where is it hidden? So this is starting from the library because we're going based off of question 2. So she's at the library. 3 blocks east, which means 3 to the right. She's at 4, negative 4, so we're going to be at negative 1, 2 after that. And then 2 blocks north, which would be up here, we would be at the soccer field for the next clue, which would be negative 1, positive 4 at the soccer field. The next clue is hidden at a location reflected across the x-axis. So, again, our soccer field was at the following, let me double check. It was at negative 1, 4, negative 1, 4. Because remember, at the library, it was negative 4, 2. We went 3 to the east, or 3 to the right, so that would leave us at negative 1. And then we went up 2 blocks. So instead of 2, we're at 4. So it's negative 1, 4. This is our x. This is our y. It is reflected across the x-axis, meaning x will stay the same, y will change. So it'll be negative 1, negative 4. Negative 1, negative 4 will get us to the playground. So our next clue for number 4 is hidden at the playground. Maria hid the next clue under a rock by the lake. How many blocks east did she have to walk to the lake? So remember, we're still at the playground. And remember, the playground here is at negative 1, negative 4. Negative 1, negative 4. That's our x and our y. Our lake, if we look at our textbook, is at positive 5, negative 4. Meaning from negative 1 to 5, we'd have to jump. So remember, from negative 1 to 0 is 1 jump. Then from 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5. 1 to 0 is 1, 0 to 1 is 2, 1 to 2 is 3, 3 to 4 is 4. I think, okay, let's restart. I got a little confused. So negative 1 to 0 is 1. 0 to 1 is 2. 1 to 2 is 3. 3 to 4 is 4. 4 to 5 is 5. And I completely lost track again. So we're going to do this way. Somewhere on there I messed up. Because that is not 5 jumps, that is 6 jumps. So even my math brain right now is not working. So we're going to number line this. 0 right here. 1, 2, 3, 4, 5. Because the lake is clearly at 5, negative 4. And this would be negative 1 where our playground is. So 1, 2, 3, 4, 5, 6 jumps. So for question number 5, Maria hid the next clue under a rock by the lake. How many blocks east did she have to walk to the lake? It's 1, 2, 3, 4, 5, 6 jumps. Let's see if my math brain can get this now. From negative 1 to 0 was 1. From 0 to 1 it was 2. From 1 to 2 is 3. From 2 to 3 is 4. From 3 to 4 was 5. And from 4 to 5 is 6. I don't know where my brain was going without the visual, but hey, sometimes you guys need the visuals. This helps, and this is fine. You could have also counted the spots on your map, on your textbook. 1, 2, 3, 4, 5, 6. So I don't know where I was doing it wrong in my head, but it's 6 jumps. And number 6. The final clue tells the hikers to walk 5 blocks north. So let's go back to where we are at. We are at the lake here. We need to walk 5 blocks north. So 5 blocks up. And then 3 blocks to the east or to the right to find the prize. What ordered pair describes the location of the prize? So let's deal with our point at the lake. At the lake, we are at 5, negative 4. This is where we're at the lake. Okay, 5, negative 4. It tells us to go up. Let's see. 5 blocks north. So our y-axis, our y-coordinate will go 5 blocks up. If we're already at negative 4 plus 5, we'll be at positive 1. So, and this is how we can do this math, we're going to be at 5, 1 once we walk up 5 blocks. Okay, and let's do this. Let's do this again with a number line. Here is 0. Here's negative 1, which is where we started. Oh no, we're at negative 4. Let's do this. We'll put 0 here, negative 4, negative 3, negative 2, negative 1, positive 1. So if we're at negative 4 and they told us to walk up 5, 1, 2, 3, 4, 5. This is how we got to 1. So we are at 5, positive 1, but then they want us to go 3 blocks to the east. So instead of being at 5, we're going to add 3 to 5 because this is our x. We're going to the right. So we'll be at 8, 1. Same idea with a different number line. Here's 0. Here's 5. 3 blocks to the east. 1, 2, 3. We're at 8. So our ordered pair for our clue would be at 8, 1. There's nothing there located on our map, but that's where our treasure would be for the location of this prize. So hopefully that made sense. Hopefully we're understanding a little bit more about graphing. Graph ordered pairs. To graph an ordered pair, draw a dot at the point that corresponds to the coordinates. So again, we start at the origin point. Our first number will tell us to go left or right. Right if it's positive, left if it's negative. Since it's negative 3, we're moving all the way to negative 3 to the left. And the second number will tell us to go up or down. Up if positive, down if negative. Since this is positive, we're going to go up to 5, and this is where I would graph my point. And I would label it M. You've noticed in the other examples, I was labeling it the coordinates itself. If it gives you an actual name for the point, just put the name. So we're going to just do it M. If it doesn't, that's when I would put the ordered pairs there. So we're going to go ahead and graph the ordered pair N, or the point N, which is -2.5, -3.5. So we know I'm going to go left, and then I'm going to go down. This is all by whole numbers. So I'm going to go -2.5, so right between -2 and -3. And I'm going to go down 3.5, so right between -3 and -4. So my point's right there, and I'm labeling it N. All right, let's see if we can do this. And I'm going to make this a little bit bigger. So we're going to graph these points. Okay, the dot's not as big as I want it to be. So we're going to go ahead and try to change this a little bit. That's too big. Yeah, we'll just go with this. So I'm going to go ahead and use a different color. For point A, we'll use blue. -2, 4. I'm going to start at 0, 0. First number is negative, so I'm going to go to the left, -2. Second number is positive, up 4. I'm going to be right there. And I'm going to label this P because it has a name. Point Q will be at 0, -4. Now remember, if one of your numbers is 0, that means you're not moving left or right. So I'm not going to go left or right because it's 0, but I am going to go down to 4. -4 right there. And I will mark that one as point Q. Now remember, point P is in quadrant 2. This is quadrant 1, 2, 3, and 4. Point Q is not in either quadrant. Point Q will actually be on the y-axis, this line running up and down, and it will be between quadrant 3 and 4. Let's go ahead and use a different color next. For point R, -1/2, -2.5. So instead of going straight to 1, I'm going to be right here in between 1 and 0. And then I'm going to go down 2.5 between 2 and -3. So my point should be right there, and that's point R. Point R will be in quadrant 3. And then we'll do a different color again. Point S will be at 4.5, 1. So again, 4.5 meaning 4.5. So I'll go right between 4 and this would be 5 right here. And I'm going to go up to 1. And that'll be point S at 4.5 and 1. Again, left and right, first number. Positive, go to the right. Negative, go to the left. 0, don't go anywhere. Second number tells us to go up and down. Positive up, negative down, and if for any reason it's 0, we don't move at all. Graph reflections on the coordinate plane. You can graph points that are reflected across the x and y axes. Remember that the points reflected across the x-axis will have the same x-coordinates and their y-coordinates will be opposites. Points reflected across the y-axis will have the same y-coordinates and their x-coordinates will be opposites. This is something that you may really want to put in your notes. Heck, you may even want to cut this out of your textbook and glue it into your notes. But this is something extremely important because if this shows up on the test, what is the definition of a reflection point? This is a great way to explain it. So for example 3, graph A, which is point 2, -4. So our point is at 2, -4. 2 to the right, -4, so there's point A right there. Graph point A, which we did. To reflect across the x-axis, keep the same x-coordinate. So point A is 2, -4. This is x, and this is y. To reflect across the x-axis, or across this way, we are going to keep the same x-coordinate 2 and take the opposite of the y-coordinate. Oh, sorry, this is across the y. This is across the x. So it'd be here. So our x-coordinate would stay the same. It would be 2. and our y coordinate would become 4, because the opposite of negative 4 is positive 4. And remember that when they say reflected across the x-axis is the fold line, if that helps. So if I were to fold this side down, these two would meet together. If I were to reflect it across the y-axis, my folding point would become this line, and this would be reflected on this side. And that reflection, if I'm reflecting it over the y-axis, the y would stay the same. It would become -2, -4, which is -2, -4. And that's what it would be right there. All right, and then let's graph B, -1.5 and 3. We go -1.5 somewhere in here, right between 1 and 2, and then up 3, so it's right there. We're reflecting it over the y-axis. Reflect across the y-axis, keep the same y-coordinate. So our 3 would stay the same. Because remember, our y-coordinate is our second. So -1.5 would become positive 1.5. And it would be 3. And our reflection point would be positive 1.5 up to 3. That's our reflection point. Notice when they do reflection points, so this is B, the reflection point would be written as B with a little line afterward. That means it was reflected. All right, let's do this got it. Graph C, -1, 5. So I'm going to go -1 and then up 5, which would be right there, and that's point C. Then graph its reflection across the x-axis. Remember, the x-axis is what is being folded, so it's going to be reflected this way. So again, -1, 5. Since it's across the x-axis, our x-axis stays the same. We are changing the other one. So this would be -1, -5. -1, -5, and it would be right there somewhere. And then they want us to graph D. 2, I'm going to go ahead and use a different color. 2, 3.5. So right 2, up 3.5, which would be right between 3 and 4. So that would be point D. And I forgot to do this last time. I should have written point C with the line. Point D across the y-axis. So this is the line that's being folded. So it's going to be on this side. This is X. Let me go ahead and erase these because these are from last time. This is 2, 3.5. And I'm going to go ahead and close the parentheses there as soon as I'm done erasing that. So X and Y. This is across the y-axis, so our y stays the same. Our x becomes -2. So it'll be -2 and 3.5. And that will be -2 up 3.5 right there. And that will be point D reflected. All right, and then, yeah, we talked about this. We're good. Do this problem to find out. Ms. Shaw is drawing a map for the school. Her room is at -3, +4, so right there. And the gym is located at +3, 4. So basically her reflection point. The library is a reflection of 3, 4, so this one here, across the y-axis. Miss Shaw's drawing a map of her school. Her room is at -3, 4. -3, +4. And the gym is at 3, 4. The library is a reflection of 3, 4 across the x. I read it wrong. Across the x-axis. So it'll be right over here somewhere. So again, the library is a reflection of 3, 4, x and y, across the x-axis, which means our x-coordinate stays the same. It's still 3, and it'll be -4. So it'll be 3 down to -4 right there. And that's where the library will be. this point is reflected across the y-axis to graph the office. So now this one, 3, -4, the office is the reflection of that across the y-axis. So x and y. The y will stay the same, so it'll still be -4. The x is what changes, so it'll be -3, -4. And -3, -4 will be right there. So this and this are reflection points of each other. This and this are reflection points of each other. These two are reflection points of each other. And if we actually pay attention, this is -3, 4. This is -3, -4. All four of these are reflections of each other in a way. And that's it. What is the figure graphed on the map? The figure should be a square or a rectangle, but it all depends on if each side is right. This is 4, this is -4. So we know that these, yeah, this is going to be a square. Each side should be the same. That's a really bad square. But this is -3, +3. It should run through there. These are -4, -4. So let's see. Hang on. I don't want to say it's a square yet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And this is why we double check. So it's not a square. It's actually a rectangle. A rectangle is the shape that we're graphing here. And that's it for this lesson. As always, you guys know where to find me if you have a question. This is it for this chapter. Your homework for this lesson will be all 14 problems. I highly suggest you guys get some graph paper to be able to put graphs in your notebook. After this, we're going to do some review and we're going to get straight to the test. Your practice tests are here if you guys would like to review some practice tests to see what your test will look like. But yeah, as always, I'm Mr. P, and I will catch you guys on the next one. Next one's chapter 6. Yay. All right, I'll see you guys soon.